Hello students, welcome back. Previously we went through the method of substitution. Let's do one more exercise. Previously we did this. Now let's go ahead with the second solution here, second problem here. Okay, good. Let's do this in substitution. Select a variable from an equation and solve with respect to that variable. Which one would you like to select? I decided to solve for y from the first equation. Why did I do that? Well, that's the simplest coefficient. I could divide by 3, or I could divide by 4, but dividing by 2 is the simplest. Of course, I could have selected x from the second equation. That's going to be about the same. But I decided to use the first equation this time. And if you decide to go ahead with the second equation, use x, that's fine. Flip 3x to the other side. 2y equals to 3x minus 1. Did I do this right? Flipping this to the other side. Change the side, change the sign. Okay, previously we didn't have to do this, but this time we need. We have to divide by 2. Y equals to 3x minus 1 divided by 2. Alright, now that I solved with respect to y, let's substitute it into the second equation this time. 2x plus 4y equals to 3. And then y is nothing more than this. So what do we have? We have an equation that is far more complicated, but only one variable. How do you solve it? The typical deal. Step 1, denominator. Step 2, parentheses. Step 3, like terms. But this time, removing the denominator is extremely easy. Very luckily, we have 4, which is divisible by 2 in this denominator here. So we immediately have something much simpler. 2x plus 4 divided by 2 is 2. 3x minus 1 equals to 3. Okay, let's go ahead. 2x plus 6x minus 2 equals to 3. Did I break up correctly? It's an easy breakup because I'm distributing a positive number. Take the like terms together. 8x minus 2 equals to 3. 8x is equal to 3 plus 2, which is 5. X equals to 5/8. Okay, alright. That's what I have. And then let's find out y. How do I get that? I could substitute it into the first equation or second equation or third equation right here. That's what I'm going to do. Y equals to 3x minus 2, 3x minus 1, excuse me, over 2, which is in this case, and let me copy and paste. And then x here is 8/5. Okay, let me expand the font. Too many denominators, so let me multiply by 8 to each term. In that case, we just get 3 times 5, 15, and then multiplying by 8. And denominator, we get 2 times 8, that's 16. So looks like we are getting 7/16. Did I do this right? Yes, x is 5/8 and y is 7/16. Of course, there can be other ways, but this is one way to handle it, the method of substitution. Okay, here's another equation. This time, here's another system of equations. Now this time we have some decimals. How do you work out decimals? Well, you can just use decimals as usual and then add or subtract. But I usually eliminate everything in step 1. You don't have to do it this way, but I just prefer to do it this way. Multiplying 10 to everything and distribute to the first equation, this becomes 7x. Oh, excuse me, not multiplying by 10. Excuse me. That was my mistake. Okay, multiplying 100 to each term of first equation. So we are distributing 100, and 100 times 0.7, we get 70, and 100 times 0.15, we get 15. 100 times 240, we need 2 more zeros. Okay, if I multiply by 10, then I could move this decimal only once, so I'm going to get 1.5 here. So still too complicated. Okay, all right, now we can go ahead and solve for one variable and substitute to the other, but I cannot resist this. The first equation can be simplified further by dividing each by 5. So dividing by 5, 3y, dividing by 5, what do you get? You get 14. Okay, and then dividing by 5, we get, is that right? No, not right. Bad idea. It was bad idea of mine to use mental math here. I should have always checked. Okay, all right. Now that looks a little bit better, and then let us go ahead with some substitution. I can always substitute from the second equation. X plus 2y equals 1000. So x is negative 2y plus 1000 from the second equation, and plug it into the first equation. What do you get? 14x plus 3y equals 4800. But what is my x? Negative 2y plus 1000. Okay, let's break up the parentheses. Negative 28y plus 14,000 plus 3y equals to 4800. Okay, take the like terms together. Negative 28 plus 3, so I'm getting negative 25. Did I do this right? Okay, flip this negative 25y to the other side. No, let me just flip 14,000 to the other side. Negative 25y equals to, this time I learned my lesson. Negative 9200, okay, all right. And then from here, dividing by negative 25, 368. Okay, there goes one of the two roots. Let's see. I don't have fractions, so I didn't need this large font. Okay, this is perfectly visible. And then as for x value right here, x equals negative 2y plus 1000, and there I'm going to substitute 368. And then again, let me use calculator to do this, not mental math. I get 264. Let's see. Is that what I got in this answer key here? 264, 368, yes, correct. So you use simplification here, and a little bit more simplification, and then I went ahead with the substitution. I could have went ahead with substitution right away, and then x equals to negative 2y plus 1000 and plug it right here right away. And then use a bunch of calculator work. Yeah, it could have worked. It would have worked just fine, to tell the truth, and a lot of students prefer that way. Me personally, I usually begin with removing all those decimals first. Okay, so much for the method of substitution. We're going to repeat some of these problems using elimination in the next video.